before going to the topic, I want to ask few questions. Like, have you ever questioned yourself that a message written by you in your computer will exactly reach how exactly it reach to the destination point, like the destined computer? Well, it is as simple as a letter written by you reaching to the particular destination, that is the desired location, because the letter reaches to the required the destination because of its address. Similarly, every computer has its own address, that is called IP address, and that's my topic. See, what exactly a IP address consists of. An IP address has 32 bits. A typical IP address consists of 32 bits, and each bit can be either 0 or 1. And the entire IP address is divided into 4 parts. Each part consists of 8 bits called octet. It's for example, like the example looks like this. This is the IP address consisting of 32 bits divided into 4 equal halves called octet, and the equivalent number of this IP address is this one. And the next question raises to you is, how do you compute this number from this IP address? Well, it's simple. First of all, what you need to do is just write the octet over here, and what you need to do is you need to number from the right side to the left side with 0, 1, 2, 3, 4, 5, 6, 7. Since it has 8 bits, it will typically range from 0 to 7. So then what you have to do is you have to multiply the bit with the 2 to the power of its index. This is called index. So what you have to do is you need to multiply this index 2 to the power of index to this bit, and after doing this summation, you will get the number. Since we have 4 octets, there will be 4 numbers, and it will equivalent looks like this. Well, next question is, how many total IP addresses are possible? Since each bit can be either 1 or 0, so there are 2 choices for each bit. Similarly, there are 32 bits. So total number of IP addresses possible will be 2 to the power of 32. So the total number of IP addresses is around 4 billion. So the next question is, are they sufficient? Since the population of our entire universe, like entire world, is around 7 to 8 billion, right? But there are only 4 billion. Let's take 70% of the users use internet. If you take that calculation, it will be around 5 billion to 6 billion. But how can they facilitate the 5 billion people with 4 billion addresses? This is a question. Actually, the IP address, the concept of IP address was proposed in 1970s. When they proposed this, they thought that we created some 4 billion address, it will be more than sufficient, because they haven't ever imagined that every single individual will use a computer, but the day eventually came. So today we are unable to use the we can't facilitate that 4 billion addresses to these many people. So the next one is how to find a solution. What's the solution? If you think rationally, you can just question like, why can't you just increase the number of bits? Yes, that's right. Even the scientists thought of same thing, and they proposed a system called IPv6. So IPv6 has 64 bits. So the total number of IP address will be around 264. That's more than enough. Okay. But the problem with IPv6 is, for example, if you go to a bank, if they give a application form, and you are asked to fill your name. For example, if the number of boxes beside your name column is around 8 boxes, and if your name is of 10 boxes, if your name take 10 boxes, what you will do? You will just you will write the 2 characters after that boxes, right? But in case of computers, it's not possible. So what you have to do is you have to destroy, because the number of bits that are allocated for a device is 32 bits. So you can't change, because it's more a hardware thing than a software thing. You can't fix the solution. All you have to do is you need to replace that with a new one. So you need to destroy the entire devices in the universe. Well, this doesn't look like a optimal solution, right? So for that they proposed a new concept called network address translation. What is network address translation? I am leaving this to you, and I hope, like, if you are interesting enough,